All right, let's look at the discussion question for module 4. So, like a lot of things we've done before, I'm giving you some characteristics, asking you to draw a graph that encompasses all these characteristics. Just like I've said before, I'm going to show you one way to meet all these. Yours is almost certain to look different, and that doesn't mean you're wrong. So let me draw the XY plot here. And it looks like I am looking at a function that is defined, or I mean, the only things are mandated here are happening between -4 and +4. So -1, 2, 3, 4. So before we start drawing anything, let's get a sense of all the things that are being asked of us. What's continuous on this entire interval, the closed interval? It's differentiable on the open interval, the entire open interval. So maybe not including the endpoints. It's increasing on -4 to 2. Or sorry, -4 to -2, and on the interval 2 to 4. It's decreasing on -2 to 2. I really just miscounted 2. Let's disregard that. It's decreasing on -2 to 2. Concave up on -4 to 0. Concave down on -4 to 0. Concave up on 0 to 4. Okay, so a lot going on here. Let's think about the increases, or let's break this kind of down into sections here. So what's happening between -4 and -2? We are increasing. And what's our concavity there? From -4 to 0. So we're concave down everywhere here. What does it look like between -2 and 0? From -2 to 0, we're decreasing. What's our concavity? We are concave down still. And then from 0 to 2, we are concave up, still decreasing. And then from 2 to 4, we are increasing and concave up. So at no point are we told where our function is. So since I did all my notes pretty close to the x-axis, let's do everything. Let's start here. Let's say that my graph begins here. All right, we're increasing and we're concave down. What does it mean for our function to be increasing but concave down? So we're going to have upward. So we're going to have upward slopes on our graph. But as we move from left to right, those slopes are going to be decreasing. So I think we need to have something that looks like this. And why does it have to come to a peak here? Well, because at this point, I'm going to be decreasing. The function is going to be decreasing, but I'm concave down. That decrease is going to be getting more drastic. So from here, I think it has to look like this. So now what's going to happen here? So as I go from 0 to 2, we are going to be decreasing and concave up. So we're still going to be decreasing, but now instead of decreasing at instead of our velocity, or I shouldn't say velocity because we're not talking about position. So I still want to have this decrease, but now concave up. We want those slopes of the tangent lines to be rebounding without ever. So go ahead and dip below the x-axis a little bit. And the reason I have to come to a valley here to come to a minimum is because between 2 and 4, I am going to be going from decreasing to increasing. And not only do I want to be increasing, I want to be concave up. So I need to be increasing at an increasing rate. All right. So I believe we have handled so far everything that deals with the increases and the decreases and the concave up and concave down. But now let's look at the others. We have a function that's continuous on my whole interval. Hopefully you can, I mean, if I were to, obviously I can't test every point, but think about what continuity means. If I were to pick any point on here, let's just grab one. What's the limit of this function as x gets closer and closer and closer to that point from either side? That limit's going to be equal to what the function is actually valued at. If I have continuity, if I have differentiability, and again, the open interval maybe not might not include the endpoints. So if I were to draw a slope of a tangent line to this curve, two things to think about. The curve is smooth everywhere, so any tangent line I would draw would be unique. Like there's no point on here which I could draw tangent lines of two different slopes that are actually going to be tangent to the curve. Again, I can't test every point, but hopefully you're convinced that that would happen everywhere. So I have differentiability everywhere except for maybe the endpoints. Because the last couple bullets here, I want to have differentiability at the left endpoint, but not differentiability at the right endpoint. So I have differentiability on the left. I think I do because I still think if I were to make a tangent line here, it would be unique and it would be well defined. So how would I make my function not differentiable at the right endpoint? Well, I have to be continuous, so it has to be defined there. So I think the only real option I have is to maybe have this trending towards a vertical tangent. So if I were to draw a tangent line at x equals 4, I am trying to represent or trying to make clear that that's going to be vertical. Again, I think while I believe this graph meets all these conditions, yours is probably not going to look like mine, but that doesn't necessarily mean that you're off. It's going to be a case by case thing. But please let me know if you have any questions.